In this video, we're going to use set transform to solve difference equations. Just like we used the Laplace transform to solve differential equation, we're going to use the set transform for difference equation. And point number one, you have to be very good with these formulae. So I have given you the formulae for set of xk plus 1, etc. And right now, pause the video, try to write this one. If you are able to write that formula, that means you have a clear idea about the pattern. So that is point number one. You have to be very good with these formulae. Okay, now the next thing, in your examination, they can use any one of this notation. Maybe they might use another, maybe like what you call, if you are studying about temperature, they can keep Tk plus 2. If you are studying about something else, maybe displacement or something, Uk plus 2. So expect any variable and any of the following notation. Okay, now the next thing, some of you might be wondering what is the difference equation. Okay, imagine you're conducting one experiment, maybe related to economics, maybe related to heat, or maybe related to something which is moving, etc. And you're asked to observe, or you're observing the experiment at certain points xk. You're observing what happened here, and maybe at xk plus 1, and maybe at xk plus 2. It can be a time interval, it can be something else, etc. And later, when you analyze, you might or you may be able to connect these things, and that connection is called a difference equation. Not a differential equation, it is called a difference equation. Okay, let's learn that with the help of an experiment. So look at this. So one guy took a loan of 1 million rupees. So he wants to start a new tech company or anything. So he took a loan of 1 million. Now look at this. Once you take loan, you have to repay the loan. And this guy is planning to pay 35,000 every month. And by the way, there is a monthly interest of 12%. So what happened here is he got the difference equation. Look. So imagine Ln plus 1 or Lk plus 1. That means the amount which has to be paid will be 1 plus r multiplied by the total amount minus 35,000. You think about it and you'll get this equation. That means the amount remaining will be the interest rate, which happens to be 12% here in this example, minus the current remaining balance minus 35,000, because every month he will pay 35,000 rupees. But every month they will add an interest of 12%. Anyway, this is an example of a difference equation. Anyway, now what we do is we will take the set transform on both sides. And then we will solve for, and then we will plug in the initial condition. Initial condition means initially his loan is 1 million. And every month the loan amount will come down, but will go a little bit up because of that interest percentage. Now slowly, by doing this process, they will get a relation which will give him the remaining loan amount. So I hope you got a clear idea about this difference equation. Anyway, now let's go for mark point of view. Okay, so I'll strongly suggest you to take a screenshot. This is the working rule. If you know this and the formula that I told you before, you will be able to work most of the problems that come in your exam. So point number one, if you are not comfortable with the funny letters, you can convert everything into xk plus 1 notation. Anyway, if you want. The second thing to do is take set transform on both sides and apply the formula. Initially I showed you all the formulae. Use the given condition. Given condition means in the loan example, Initially, what was the loan amount? 1 million. Similarly, in every difference equation, they will give you initial condition. Now simplify, simplify, simplify till you get the function in Z. And use any inversion technique. There are many inversion techniques, but I love partial fraction method and residue method. So are you ready with a pen and a paper? So look at this, we have a difference equation. So you can convert this into any notation that you are comfortable with. If you want, you can write this as x k plus 2 plus 6 times x k plus 1 plus 9 times y k is equal to 2 to the power k. Or if you don't like this, you can leave it like this. Anyway, the first thing I did is I am comfortable with this notation, so I converted into the notation, and we have the initial condition. And look at this, the initial condition will be given in the question. The next thing to do is you take Z transform on both sides. Don't forget the working rule. It's so simple. Convert it into any comfortable notation. Take Z transform. So I'm going to take Z transform. So here we have y k plus 2. I just copy the equation. Plus 6 times y k plus 1 plus 9 times y k is equal to 2 to the power k. Now Z transform is linear, so this step is like so easy for you. Now the main step, do you remember this formula or not? So I hope you remember the formula. Now apply the condition. So the initial condition is given in the question, so 0 and 0. So I'm going to apply the condition, minus 0 divided by Z minus 0, and then the critical step, slowly find x of Z or y of Z or u of Z. Anyway, you'll get a function in Z, and I end up with Z minus 2 into Z square plus 6Z plus 9, and I'll simplify as much as I can, and I got this. So this is equation number 1. So don't forget the working rule. We will read the working rule once more. Change it into any comfortable notation, take Z transform, apply the formula, use the condition, simplify till a function in Z comes common. So you got the function in Z. Now you can do the remaining part by yourself because it's just taking Z inverse. So you have two options. If you want, you can take partial fraction. I hope you remember, in partial fraction method, you have to multiply both sides by 1 by Z. In residue method, you have to multiply both sides by Z power k minus 1. Anyway, I'm going for residue method. So we have our function here. So I'm going to create Z to the power k minus 1, and function of Z will be Z to the power k divided by. I'll strongly recommend you to pause the video and try it yourself and check whether you're getting the last answer or not. So this will be Z minus 2, Z plus 3 the whole square, and there are two singularities. So what are the singularities? Z equal to 2, Z equal to minus 3. So this is a symbol pole, and this is a pole of order 2. Now I'm going to calculate the residue. Residue 1 will be limit Z tends to 2. It's a symbol pole, the formula symbol. Z minus 2, Z to the power k divided by Z minus 2, Z plus 3 the whole square. I got the answer 2 power k by 25. Confirm it. Now I'm going for the second residue. It's a double pole. What should I do when I have a double pole? Yeah, order minus 1 factorial. Limit Z tends to minus 3. Look at this. It's a pole of order 2. So I have to differentiate once. Z minus minus 3 will be plus 3 the whole square. Pole of order 2. Z power k by Z minus 2, Z plus 3 the whole square. So we have to do some differentiation. This will become 1. So limit Z tends to minus 3 d by dz of Z power k by Z minus 2. See, if you learn complex analysis properly, you can do this application like really fast. Z tends to minus 3. How do you do u by v rule? Denominator derivative of numerator minus numerator derivative of denominator divided by, okay, and then you plug it here, so we'll get minus 5 k minus 3 the whole power k minus 1 minus minus 3 the whole power k divided by 25. Now we can split this, so this becomes minus 5 k. I hope you remember a power m plus n is a power m a power n, so this part becomes minus 3 the whole power k minus 3 the whole power minus 1. What is a power minus 1? 1 by a. So what is minus 3 the whole power minus 1? 1 by 3. This step might look silly, but in the answer paper I see many students making a mess with this. The whole power k by 25. So I'll leave the remaining part. I got the answer like this. So see, we got the sequence from the difference equation. Now I hope you understood the method. Let's make the method even more clear. Okay, so we have another question. Solve the difference equation. What do you mean by difference equation? When you are working on an application, you start observing something at certain points, and later by your experience you will be able to connect them, and the connection is called a difference equation. Anyway, mark point of view, you'll be given a difference equation and a condition. First thing, convert it into any notation that is comfortable for you. I love this notation, so I'm not going to convert it. Now step number 1, take set transform and apply linearity, so I'm going to get it. Now formula time. Formula time, I know the formulae, so I'm able to write this step. In examination, I'm sure you will be good with this part. So now next thing, apply the condition. Oh, this problem is like really easy. So this is going to vanish. So we get z x plus x is equal to z by z minus 1. Now we have to extract it, z plus 1, z by z minus 1. So I got the function in z equal to z divided by z minus 1, z plus 1. That's it. After this, you know what to do. We have to find the inverse. The inverse of this function will be our sequence, which is our answer. Now we have two methods. What are the two methods? Partial fraction. When you work on partial fraction, don't forget you have to multiply both sides by 1 by z. If you are working with residue method, you have to multiply by z power k minus 1 and then proceed. Okay, once more I'll repeat. Many students forget this. So don't forget, multiply by 1 by z, multiply by z power k minus 1. And at the last, don't forget to add the residues. Okay, so let's use, I guess I'll use partial fraction. So what should I do before using partial fraction? I have to write 1 by z of xz is equal to 1 by z, and this will get cancelled, so you'll get 1 by z plus 1. So 1 by z x of z is equal to, I'll convert it into partial fraction. Come on, pause it and try it. I got 1 by 2 and minus 1 by 2. Okay, now what will I do? I'll multiply both sides by z. So 1 by 2 comes common, z by z minus 1, z by z plus 1. Anyway, now all I have to do is take z inverse on both sides, because I am applying partial fraction method. Formula time, what is the inverse of this function? Yeah, 1 to the power k, which happens to be 1. And this will be minus 1 to the whole power k. That's it. If you want, you can try this with residue method. Okay, now let's solve one more problem. This problem is a little bit tough just because many students don't know the formula for, the Z transform of delta function. Anyway, what is step number 1? Take Z transform on both sides. and then apply the linear property. So we get z of xk plus 2 minus 1.3 z of xk plus 1 plus 0.4 z of x of k is equal to 1, because z transform delta function is 1. It is not unit step function. Now here we have the formula x of z minus x of 0 minus x of 1 divided by z minus 1.3 z multiplied by x of z minus x of 0 plus 0.4, the whole stuff will become function of z is equal to 1. Now let's apply the condition. This problem is like really nice because the initial condition is 0, so this is going to vanish, this is going to vanish, so we can take that function of z common, z square minus 1.3 z plus 0.4 is equal to 1. So use a calculator or otherwise you can factorize this. I hope you remember a quadratic can be written as z minus alpha into z minus beta multiplied by capital A. Don't forget multiplied by capital A, where alpha beta are the roots of this equation. So x of z will transform into z minus 4 by 5. I got 0.8, that is 4 by 5 multiplied by 1 by 2, 0.5. And now you know what to do. You have two options. Option number 1, partial fraction. But remember, don't hurry. If you are going to apply partial fraction, multiply both sides by 1 by z. Anyway, I don't prefer partial fraction. I love residue method because both are symbol poles. By the way, if you are applying residue method, multiply both sides by z power k minus 1. Anyway, I got the last answer to be x of k equal to 1 by 0.3. You might get a fractional answer, that's also okay. 0.8 the whole power k minus 1 minus 0.5 the whole power k minus 1. So that's it. Practice a lot of problem similar to this so that you will be like really good with difference equation. So I'll be back with more videos. So till then, my friends,